Good day, everyone. And once again, we are back together and welcome to our YouTube channel. For those of you who are new, please just make sure that you hit that subscribe button as well as the notification bell. And once again, for those of you who might need assistance in mathematics or physical science, let's be your plug. And our email address is info@mlungisinkosi.co.za. All right, so we're continuing on our lesson. Okay, so we're still looking at the geometric series or the geometric sequence. Now, in this particular case, I want us to look at the sum of a geometric sequence. Now, there are two cases, right, that I'm going to mention. So when we take the sum of a geometric sequence, we have the formula. It says Sn is equals to A. Now, this is going to be r to the power n minus 1 divided by r minus 1. Now, this is for the case where r is greater than 1. Okay, so this is the first instance. So whenever it is that we've got the common ratio, and of course I've already mentioned what A stands for as well as R. So when we've got the common ratio, in this case to be greater than 1, then we can use this formula. However, when we have R less than 1, then we use it's the same formula but just expressed differently. Okay, so this is where R is less than 1. Okay, so so in this case, we're going to simply have 1 minus r. This is for all cases where r is actually less than 1. Now, ladies and gents, what does it mean when r is less than 1 or where it's greater than 1 or whatever the case may be? Right, I want you to keep in mind that r is the common ratio, which means that in this progression, what we are doing is that we are moving to the next term by multiplying by a constant. Okay, so that simply means, let's say we've got a progression. Let's say we've got 1, 3, 9, and so on and so forth, right? So we know the value of A is 1. We know R. For you to move to the next term, what did we do? We multiplied by 3. For us to move to the next term, what did we do? We multiplied by 3. So now when we look at our common ratio, in this case, R is actually equal to 3. Of course, now, if I say to you, evaluate, the sum of the first 10 terms of the sequence. So now, you've got the value of A, you've got the value of R. But now, which formula are we going to use? You'll say to me, okay, well, R is actually greater than 1 in this case. So we're going to say, okay, so to get the sum of the first 10 terms, okay, so this is going to be S10, okay, this is going to be A, r to the power n minus 1, okay, divided by r minus 1. So, in fact, what we're now going to simply do is say, well, we know the value of A is 1. We know R is actually equal to 3, so this is going to be 3 to the power 10 minus 1 divided by, now I'm just going to pull this up a little bit, okay, now the value of R, we said that's 3 minus 1. So this is how simple we'll get the sum in this particular case. I'm just going to throw in some terms there. All you need to do is just put this in your calculator. Let me do that quickly. If you can try and do it as quickly as you possibly can, that would be really helpful. So this is 3 to the power 10, okay, minus 1. Just be careful when you are pressing on your calculator, especially when you are, you're dealing with an exponent, okay? Make sure that you put down that, that cursor. All right, so the value that I get there is 29. Perhaps I should download an emulator so that I can be able to show you every time I calculate. So in this case, that's 29,524. Now, what you'll realize here is that every time you're making a calculation, you'll see that the value gets bigger and bigger. Now, we call this a divergent series, okay? We call it a divergent series. What do we mean? We say the further we move, away from our terms, or the further away we move from, let's say that's 1, that's 3, that's 9. So obviously, every time you are tallying up, you are counting up the sum, the number simply gets bigger and bigger, okay? Of course, it does make sense. But what it also means is that in this sequence, if I were to kind of draw it as a, you can imagine that the progression, the further you go towards infinity, right, the numbers simply keep surging up, okay? Keep going up. So we say it's a divergent sequence, right? However, suppose we were to have a situation. Let me just make a progression there. Okay, say we've got, let's have 1 over 2, 1 over 4, and so on and so forth. Now, here we've got another sequence, right? But in this case, what would be our value for R? Of course, you're going to find the common ratio. How do we find the common ratio in this case? Or well, do we have a common ratio? That's the first thing that we should check. So let's see, how do we find the common ratio? We said to do that, you simply say T2 divided by T1. So let's see, what do we get? We will get 1 over 2 divided by 1, and that gives us 1 over 2. That's a half, right? But would that be the same if we were to take T3 over T2? Of course, we're not going to waste time. We've already covered this. Okay, so you're going to say this is 1 over 4 divided by 1 over 2. Now, I honestly want you to be very careful when dealing with fractions, and perhaps what I will do is just have a lesson on fractions by itself, okay? So when I'm dealing with this fraction, I'm going to simply say, okay, so I've got 1 over 4 divided by, now I'm going to simply have divided by 1 over 2 and express it like that. But remember, when I'm dealing with fractions, okay, I can convert that division sign into multiplication, but in order for me to do that, it means that I need to now invert the other fraction, okay? So that now becomes 2 over 1. Please keep that in mind. So what I'm going to have is 1 over 4 divided by, multiplied by 2 over 1, and I can simply multiply the numerators. 1 times 2 is 2, and 4 times 1 is 4. And you'll see 2 goes into itself once and it goes into 4 twice. So this is the same as 1 over 2. So definitely we've got a constant, or a common ratio in this case, to be 1 over 2. Now, if I were to ask you to calculate the sum of the first 10 terms, okay, so S10 for this one here, so you'll say to me, okay, the value of R is less than 1, okay, meaning that it is, it's less than 1. So what we're simply going to say is A, that's 1 minus R to the power N, divided by 1 minus R. So all we simply do is just to substitute once again. Our value of A is 1, okay, that's 1 minus, we said R is 1 over 2, okay, to the power N, and we said this is the first 10 terms. In fact, let's do this. Let's put that in square brackets, divided by, now this is going to be 1 minus 1 over 2. Okay, so please keep in mind, very important for you, every time that you make a calculation, to be mindful whether R is greater or less than 1. Okay, so I'm going to quickly just put that in my calculator there. Okay, so we've got, this is going to be 1 minus, okay, and I did say for your benefit, in future what I'm going to do is just download an emulator so that you are able to to see that as I calculate. Okay, and then divided by 1 over 2. Okay, right, 1 minus 1 over 2. Okay, and I get a value there. Right, you can express it as a fraction. The value that I got there was 1023 over 512. Okay, so this is the sum of the first 10 terms. Okay, and which is approximately equal to 1.2 because it's 1.998. So this is approximately equal to 2. Okay, right, now ladies and gents, what I want to quickly do is I just want to quickly jump into talking about the sum to infinity. Okay, now we say that when r, the value of r, is less than 1, we say this is what we call a convergent series. It converges towards a particular, it converges towards 0 in that case. Okay, so it means that the further you go, now I want you to think about it. You start with a number. Let's say let's take a progression. Let's say you've got 8, and then you've got 4, you've got 2, you've got 1, and you keep going. What's happening in this progression? It is definitely a geometric progression, but the difference is that the numbers are getting smaller and smaller and smaller. Now you can imagine that the further you go towards infinity, they get so small that you actually end up with a number as close as possible to to 0, right? So meaning that you can actually find out what is the actual sum to infinity. Okay, so what I want us to quickly do is let's talk about the formula of the sum to infinity. Okay, so let me actually take the very example that I made here so that I can illustrate using it. Okay, so if I have got this particular progression, it means that as I move towards infinity, the numbers get so small and small and small that they actually move towards 0, and ultimately you can actually get the sum to infinity. If I had the time, I would actually illustrate this to you better, okay, so that you can see it. All right, so what we're going to do is, right, what is our value for a? Our value for a in this case is 8, okay, and our value for r, if you take t2 divided by t1, this is going to be 8 divided by 4. Actually the other way around, sorry about that. Okay, so that's 4 divided by 8. So that's 4 divided by 8, and of course you can do the same with t3. Just don't want to waste time with it. So in fact that's 1 over 2, right? Okay, sorry that I'm using the same common ratio again. Okay, so what I want to do is talk about sum to infinity. So I've already established that my value for r is between -1 and 1. Now remember, once this is the case, then we say that our series or our sequence is convergent. We did say that, right? Okay, is convergent. Remember, it converges. What that simply means is that, as you get the numbers, they get smaller and smaller, and they sort of lean more towards a specific number, in this particular case 0. Okay, So now what we say is the sum to infinity is simply going to be a divided by 1 minus r. Now, I could show you where this comes from, but that's another discussion for another day that will have a different purpose all by itself. So what we're simply saying is that when you calculate the sum to infinity, you can only do that for a convergent series, okay? Meaning where r, the value of the common ratio, is less than 1 and it's greater than minus 1. So let's find out for this one, what would be the sum to infinity? So that would be a. What is our a value? Our a value would be 8, okay? And what is our r value? We just found out that our r value is 1 over 2. So our sum to infinity, this will be 8 divided by 1 minus 1 over 2, that's 1 over 2. And this is simply going to give us a value of 16. So it means the sum to infinity for this particular question is 16. Okay. All right, let's take this as our next example. Let's say if the sum of 5, 15, and 45 to n terms is 605, okay, find the value of n. So there are two things that we need to establish here. What is our a value? So without any waste of time, we know our a value is 5. What is our r value in this case? So that's going to be, so to move from the first to the second term, okay, you realize there we've got 15 divided by 5, that will give us 3. And of course, 45 divided by 15 will also give us, so we're taking term 2 divided by term 1 as well as term 3 divided by term 2, and that gives us a value of 3. I'm not going to waste time with that. Okay, so now we want to know how many terms will give us a sum of the sequence. Definitely it's a geometric sequence, so let's find out. So in this case, the sum of the n number of terms, now our r value is greater than 1. So in this case, we're going to say this is a r to the power n minus 1 divided by r minus 1. So quickly, let's do that. So this is going to be 5. Okay, so that's 3 to the power n minus 1, okay, divided by 3 minus 1. And all of this is equal to 605. So now we have to kind of work with exponents, we have to work with fractions, and so on and so forth. So in this case, we've got, okay, let's simplify this. So this is 5 over 3, okay, 5 over 2, 3 minus 1 there, okay, 3 minus 1 gives us 2. Yeah, this technology. Right, so 5, there's our 5 there, divided by 3 minus 1 gives us 2, but all of this is multiplied into 3 to the power n minus 1, okay, is equal to 605. Now, if I may quickly just show you, so we've got a coefficient, a fraction as a coefficient there. So all I'm going to simply do is just multiply by the inverse of that fraction. That's 2 over 5. But remember, what I do on the left, I have to do on the right. And the reason I'm multiplying by 2 over 5 is that those will cancel out. So I've got 3 to the power n minus 1. Okay, so I'm going to say 605 multiplied by 2 over 5, and I get 242, okay? And if I take the 1 to the other side, remember we cannot add it to the 3 to the power n. They're unlike terms in that case. So we're going to have 3n. If I take it to the other side, it will be 242 plus 1, so I'll have 243. Okay, so either you can use logarithms or we can just simply find out, okay, what are the factors, or rather, what is the power of 3 that would actually give us 243. Right, so to be quick about it, you can just simply introduce logs and say, well, this is going to be log of 3 to the power n is equal to the log of 243. Okay. Of course, the law of logarithms says, okay, if I've got a power there, it can jump down, that jump down rule. So n log of 3 is equals to log of 243. And you can divide both sides by log of 3, divide by log of 3. So our value for n, right? Let me do that quickly. So log of 243. And I'm going to divide that by log of 3. Okay, and my answer is 5. So it means that the sum of the first 5 terms will actually give me that value of 605. I hope that makes sense, ladies and gents. And I just want to make maybe just one last example that we can use, and we conclude. All right, actually, let's leave it right here, right there. I think I want to leave this lesson where it is. And if you haven't subscribed, please just make sure that you're part of the family, and that you make this channel your home and your go-to plug. And for all those who are in matriculants, and also those who are upgrading, please just make sure that you work hard, work consistently, and make sure that you make the best of this opportunity. This opportunity are very rare in life, and use this channel as your plug so that you can get yourself ahead. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.